Well, hi everyone. I'm just getting myself set up. How are things? Silence is deafening.
Pretty good.
Very good, thank you. At least I know one of you is alive and can still speak. How's things going, Natalie?
So far, so good. Is there a Zoom meeting tomorrow at 1?
Yeah, we're going to do the change of variables then. So today I'm going to focus on the cylindrical stuff. Have you had a chance to look at those questions? No, okay, so this will be hopefully useful. There we go. So in general, are things going okay? You're not feeling hopefully too overwhelmed?
So wait, even if there's that meeting tomorrow, is there still going to be the normal class meeting on Friday?
Yeah, that's going to be the last chance for you to get any kind of help on the sections that we've got. You are going to find, and I've already mentioned that to other people, that the change in variable section is going to be scary. Well, not that the other two are easy, but it's going to be especially scary. So the more times we can hit that and go over questions, I think the better it'll be for you. I think I am staring at myself, so I should be able to reverse it. Come on. Okay, I'll just do it this way then. Okay, I guess we should officially start. Good morning, everyone. Or technically, I guess good afternoon. Is there anything in general that you want to talk about? Any questions before we get started? Okay, I'll assume that we're good to go. See if we can see if we can get a little bit better. There we go. Okay, so let's start looking at cylindrical coordinates. Now, some of you may have seen this, but it's always good to start at the beginning. What we're trying to look at is alternate ways of telling someone where an object is a point in 3D space. And the reason why that is helpful is that when you do certain triple integrals, it's difficult to do them if you leave them as x, y's, and z's. But if you convert them into what we call cylindrical coordinate scheme, then the integral becomes much easier. And that's essentially the reason why we learn this technique. And then after that, there's another section called spherical coordinate system, which again is just another way of measuring an object in 3D space. So instead of saying x along, y along, z up, you use a different method that uniquely describes that point in space. So imagine I have a point over here in space. So you're going to have to imagine that as a point in 3D, right? Sticking out the paper kind of thing. Now, the usual way is you'd say x along, y along, z up, and that would be it. In cylindrical, what you do is you imagine that point there being the vertical distance to the floor, the xy plane. And then what you do is imagine that there was a big circle on the floor. So that magic point there, where it hits the floor, it's on the circumference of a circle. You then join a line from the center to there, and that distance we call r, and the angle you make with the x-axis, this angle over here, is called theta. So if you want to describe a point in 3D space using cylindrical coordinates, you will say the r is 4, the theta is 30 degrees, more likely the theta is pi over 6, because we typically always use radians, and the z value is still the same z value. We've actually done a couple of integrals, triple integrals before, where you did that. Can you remember some of the ones where the shape on the bottom was a circle, so you just converted it into polar to make it easier to do? You were actually in those questions using cylindrical coordinates. We just never told you that's what you were doing, right? So it's not totally new, it's just we're formalizing a little bit. Now, if you do a normal triple integral over some region E of some function f, x, y, z, and then you do it, let's say dx, dy, dz. What does that translate? Well, you're still going to do it over the same region. The function x, y, and z gets a little bit mucked about with, but what's the x becomes r cosine theta, the y becomes r sine theta, and the z stays put. And do you notice that you add in an r, just like you would do in polar? So it's still going to finish with not dr, d theta, dz, but an r times dr, d theta, dz. Any questions? Are we following along pretty well? I'll take it, we're good. Just letting a couple more people join. So far, so good. Now, f, x, y, z could be anything, but if you're going to use cylindrical coordinates, it's probably not going to be too different. There tends to be a theme in the functions where this is desirable. If you ever see a function, you know, x squared plus y squared minus 4, right? If that was the fxy, some with x squares and y squares in it, that's a good candidate for cylindrical coordinate scheme, right? If you notice that the floor is a half a circle or a whole circle or something circular or elliptical, you can do it with that as well, right? The chances are you're going to do cylindrical coordinates. The good news is you don't need to decide, when do I use cylindrical coordinate scheme? Because pretty much all the questions, that's what you're going to use. So you don't need to say, do I use this method? Do I use that method? Do I use this third method? You're just going to focus on cylindrical coordinates. But in the big scheme of things, if someone just said, here's a region, here's a triple integral, go and get the answer for me, right? With no other clues. You could go dx, dy, dz, right? Could be a possible. You could go this new guy, cylindrical. You could go another guy called spherical. And then the last guy in the list, the one I keep threatening you with, you could do a double change of variable, but they are typically only going to use for double integrals. So you can do them for triple integrals, but we're not going to look at them. So let's kind of the general theory of how you get the thing. Let's take it and do a question. So suppose that the region E, so this is just my example. Suppose the region E is described as the set of all points, x, y, z, such that x squared plus y squared is less than or equal to 7. And that z is between 1, well, you can write it different ways. Let's say z is between 1 and 4, right? So I've got a region that is basically what? A disk on the floor, radius 7, and it starts at a height of 1 and it finishes at a height of 4. So can you imagine that region E is just a tin can floating in space, about 1 foot off the floor, right, from 1 to 4. Now, what's going to happen to that region is that there's a function, x, y, z. In this case, the function is going to be called x squared plus y squared plus z squared, because I want it to be. And what that says is that every single point in this region, this 3D region, it has another dimension to it, this x, y, z. Don't try and visualize these, because technically this is a fourth dimensional object. Instead of visualizing it, just think of it as maybe a temperature function. So at any given point in that tin can that's floating in space, the temperature is whatever the x squared plus the y squared plus the z squared is, right? Just think of it as like a practical example, right? So what you're doing when you find the triple integral of this function is you're finding the total amount of heat energy in that tin can, right? So it's not a 4D, forget it. Your brain can't handle, I can't handle 4D, but I can handle a 3D object having a fourth property at any given point within it. So what you're doing when you find a triple integral is you're adding up that fourth property over a region. So our guy would have started life off as a triple integral of x squared plus y squared plus z squared, I guess dx, dy, dz, but it's going to be transformed now. Now, x squared plus y squared, let's take care of that first. And maybe I should bring this fella back for a minute. The x coordinate gets replaced by r cosine theta, right? The y coordinate gets replaced by r sine theta, and the z coordinate stays put as a z. But there are other connections here. Don't we, for instance, very often end up using this property as well? Right, so back to the question that I had here. The x squared plus y squared guy, what does he look like if you convert him to essentially the polar piece of the puzzle? The x squared plus y squared, what does he become?
7.
Yeah, r squared. So this fella looks like that. Now, I can set up the limits of integration here. In this particular question, every single one of them's a number, right? So the z's go from this to that, the r goes from this to that, and the theta goes from this to that. So in that particular situation, you really don't, it doesn't matter who you do. But I'm going to try and get into a kind of scheme of things. So I'm going to do the z's first. And then I'm going to do the r next. And since it's this fella here, won't we go from r equals 0 to r equals the square root of 7? You happy about the square root of 7? We're good? Right, and theta, it's a whole circle. And then I would do the z's first, then the r dr d theta. So what I've now got is a triple integral using r, theta, and z. All of the limits of integrations are numbers, and the thing I'm going to do it to is an r squared plus z squared dz r dr d theta, right? So far, so good. Are we all comfortable with that process as it stands right now? Right, now, to save time, I'm just going to write the numbers 0 and root 7. I find it helpful to say theta and r, but that might not be that helpful to you, so you don't need to if you don't want to. And as always, you do that guy first, right? Now, I've got a little r fella floating out here. Do you know I could bring him in here, or I could leave him out here? Won't it make no difference to the final answer? Right? Yeah, the final answer will look the same with or without it, so I'm just pretending it's not there for the time being. So we have r squared z plus 1/3 z cubed, evaluated from z equals 1 to z equals 4. Then we're going to go r dr d theta. Now that's going to become the integral from 0 to 2 pi, the integral from 0 to root 7. If you plug in 4 here, you get 4r squared. If you plug in 4 here, you get 64 thirds, I believe. And then you take away, try to check this, you take away an r squared and a plus 1, and you have an r dr d theta. Now, by now you should be getting good at me not being great at counting. Does that look okay? We got a thumbs up on it, so I'm going for it. So all I'm doing right now is tidying things up a little bit. Okay, that and that gets me 3. That, take away that is 63, but 63 thirds is 21. So I believe that's what you end up with. Again, does that look good? Yeah, okay. Now, all I'm doing now is thinking about making my life slightly easier. And you've seen this trick a lot of times, but every time I say it, I like to show it off. Do you notice that you could really take this whole chunk here and then just separate this fella? So what I would do is I would look at this question and I'd say, it might be easier to do the integral from 2 pi of 1 d theta, and then the integral from 0 to the square root of 7 of all this stuff, which is what? 3r cubed plus 21r dr. And if we found those two integrals separately, couldn't we just multiply the answer and call it good? Are we comfortable so far with the whole process? I'm just dotting this guy. I mean, you could figure out what it is. They're never pretty, right? But it is what it is. Right, that's a pretty straightforward one without too many frills. I'm going to use this example and just tweak it a little bit to try and get some mileage out of it. But do you get the process that when you're changing from normal x, y, z to cylindrical coordinates, all the x's and y's have to be turned into r cos thetas and r sin thetas, and hopefully simplified a lot. And whatever the region is, the E, it has to be converted into a polar way of looking at things, right? Essentially a polar way of looking at things. And normally if you look at the floor, it's x squared plus y squared. Technically speaking, do you know you could have an x squared plus z squared and have the cylinder going horizontally on you? So you just have to kind of change the x and the y is now an x and a z, you know, kind of variables can switch places, like, oh, I'll go in the front now and you can go last. But the process doesn't change. It's just a labeling idea, you know. An analogy. We use x, y, and z. Makes sense, 3 dimensions, x, y, and z. We tend to think of z as being somehow different from x and y. We tend to think of z as being up and down, don't we? Because, well, that's how I see it, right? X, y is the floor, and I've said it myself, right? Z is going up or down, right? Plus or minus. Can you imagine that this is a 3D coordinate system out in the middle of space? You know there is no up in space. Z is no more up or down than X and Y is. So can you see that you could take your X, Y, Z and orientate them any way you like, and the math doesn't care, as long as you're capable of doing the switchover, right? So what happens if the Y is being treated like the Z? So, you know, if they swap places. If you can handle that, then that'll take care of one of the little idiosyncrasies that you get. Back to, I promised that we'd do a little bit more with this question. I know this is not the right answer, but I want a number that's easy to work with. So can we pretend it's 42? One of my favorite answers. And then let's go back to the original question, which was find this triple integral. And let's suppose that the question was actually find the mass, and that this guy here was actually the density function. Do you see that the question hasn't changed? All you're finding out is that in that situation, the 42 represents the mass of that floating cylinder, right? Now, if that was the question and you've now found the mass, if you wanted to calculate, just for example, we'll do one of them, x bar, wouldn't it be 1 over the mass, the triple integral over E of our function, I better call that rho, of our function, dx, dy, dz. And sorry about that mess. There's something missing from this formula. If I want to get x bar, it's not just 1 over m, this triple integral. What's the piece that's still, it should be there and isn't?
X inside of that.
X inside of that, right? Now, if I then translate that into 1 over 42, because we pretend that was what m is, the 0 to 2 pi, the 0 to root 7, the 1 to 4, we're good with that. We have an x followed by what, an x squared plus y squared plus z squared guy. And then I suggest we do the dz, dr, d theta. So do you see how it's not that different from what we just did, right? Tidy it up a little bit more. The x becomes r cosine theta. The x squared plus r squared is still this guy. That guy there is still z squared. And then we have a dz, an r, dr, d theta. Are we comfortable with the transfer, the changing of the various pieces? Now, this mess here, you can simplify it a little bit. So what I'm going to show you is a trick in algebra that you may have done before. Sorry about the mess. Right. I am going to pull out an r, this r, and a cosine theta. And I am just going to leave r squared plus z squared inside. R has got nothing to do with dz. R can be thought of as a constant. If you're a constant, you can pull it outside the integral. Only pulling it out, not to the end, just outside that one integral. The cosine theta, same thing. Do you notice that R, the second R with this R is where the R squared came from? Now, all I'm doing here is to try and reduce my workload. If I didn't do that, it would still work. I just have a lot messier pieces. Now, I have to keep this R squared because it's got a plus next to it, right? It's an R squared plus a Z squared. Now, if that had said R squared times Z squared, do you know I would have to pull that R squared out as well from the whole other bits and pieces? And only focusing on the piece that the absolute minimum piece that I need to successfully integrate this thing. And can you see that might reduce your workload a little bit? It saves you having to write down a whole load of stuff and take it away with a whole load of other stuff. And it really doesn't matter, right? Now, this bit I'll take one stage further. Right, this fella here becomes R squared Z plus 1/3 Z cubed. And I'll evaluate from Z equals 1 to Z equals 4. And then we have a dr d theta going on. Do you recognize anybody that we've already found the answer to? Do you recognize that that has already been found earlier on? So all I would do is I'd go back and look at my first page of working. Remember that guy? Which became that guy, which eventually became that guy. You see what I'm doing now? I'm just using the same calculation, right? The integral of r squared z plus 1/3 z cubed from z equals 4 to z equals 1. I'm using that same result, right? And I am using it to reduce my workload. And as long as I've copied it down correctly, I think it ended up being 3r squared plus 21. You happy about that? Although, I mean, these are just shortcuts. They are not necessary. If you go and you say, yeah, too much going on there, just integrate it the way you would with all the pieces. There'll just be a little bit more paper, but you'll get there, right? Now, at this point here, I think we should be able to split this up, shouldn't we? We should be able to keep all the things that got r squared. So it's going to be these two things. And anything that has a theta. And then find this integral the usual way, find this integral the usual way, and then multiply the results. Remember to multiply by 1 over whatever the right answer is, 42, and off you go. Does that make sense? All I'm doing is, as these questions are laboriously, notoriously long to do, so any tricks of the trade you can come up with to reduce your workload. Oh, I've already done this integral and I know what it's equal to. So I'm not going to do it from scratch. I'm just going to look at what I got and write it down, for instance. Shouldn't you use as much symmetry in the answer as you can if you're doing centers of mass, right? If you know that the x's and the y's are essentially symmetric to each other, I don't know what this answer is, but it's 32, no, that's a bad choice. It's 31 42s. Pretend it is. If x and y are symmetry, I don't bother with that guy because he's going to be the same guy, for example. Right? So always look for anything that's going to reduce your workload. I doubt it very much, but I guess if everything was symmetric, which I strongly doubt it would be in this question, then I guess all three would be. But I don't think that's too impossible. Wasn't there a cuboid question where all the lengths were L or something, and they wanted the center of mass of that thing? And I think and whatever the number is, it was the same number for X bar, Y bar, and Z bar. So, you know, maybe you'll get lucky one day and you'll get a question where you only find one of the three and then the others are obvious from that. Any questions so far? You know, I've kind of jumped around a little bit, but that's the way my brain works. So if you get a question involving creating from scratch a cylindrical coordinate triple integral, at least if it's like that one, you feel comfortable about how you're going to do it. So I'm going to go in and pick up the question if I can find where I've darn put the thing, of course. I haven't done jokes for ages. Has anybody got a joke for me? I don't hear many volunteers here. Nothing?
You should tell one.
Well, I know I'm going to tell one, but I would like one anyway. Have we
What do you
got it?
call
We don't have.
what do you call pig that does karate?
I don't know. What do you call it?
A pork chop.
Oh, God, that's bad. Right. Oh, this is a very old Scottish joke, and I guess some jokes don't transfer culturally, but I'll tell you anyway. If you've ever got me on the Underground situation, you'll hear a lot of Scottish jokes involve. They're quite cruel, so this one's no different. So, we were really poor when we were young. This is a joke, by the way, although I was really poor when I was young. We were really poor when we were young. In fact, we were so poor that we didn't have we couldn't buy clothes. So we couldn't go out and play in the street with the other kids. And then one day my dad bought me a hat so I could look out the window. Oh, come on, that is a classic Scottish joke. You don't get it? He bought me a hat so I could at least look out the window. Okay, two of you are nodding. I guess you know, that joke's just over your head, right? Just okay. What other one? Oh, Scottish guy was and his friends were playing golf, and he's a fanatic golfer, and he's about to take his, hit his ball, and he around the outside of the golf course, a funeral procession was driving by, and instead of playing his shot, he actually stood and he took his hat off and he bowed and he waited till it drove by and round the corner and out of sight. Then he put his cap back on and he's about to take his shot. And his friend says, "No, I know you're a fanatic golfer. You play golf every day." He says, "I was impressed that you stopped there and, showed a bit of, civility there." And the Scottish guy took his cap off again and said, "Yep, she was a good wife."
Oh my God.
God, you're lucky that you don't get me by ground, because see if you're in ground, you can't avoid these jokes. At least right now, some of you could be muting and I wouldn't know. So that's at least something. Well, right. Anyway, I'd set up some things. Am I getting some chats I should be looking at? Okay, I've been told that the homework is not set to 6 attempts. Kind of hard for me to do it when this lesson is off, but I'll tell you what, once we're finished, I'll go in and do that. Yeah, you probably need 6 attempts on some of these questions, hopefully not. What I'm going to do is do a share screen. We've got about 20 minutes, although I've got another meeting, so we've got about 10 minutes, so we've got enough time to have a quick zoom around and see what the thing looks like. What the heck is this? No, that's not the one. I'll try again. I did open it up, so why can't I see it? It's not that one. Might be that one. It's not that one. Okay. I did open it up. I know I did. Let's see. Oh, you have to have it open on the page. This is such a pain in the butt. Right, give me a second attempt at doing this. I think I've got it this time. Looks good. Right, let's go stop sharing. Back to sharing again. Right. Are you looking at the WebAssign page now?
Yeah.
Yeah, okay. So cylindrical coordinates. Are you looking at the cylindrical coordinates part?
Yes.
Right, so I can go here and we can do that good, right? So let's expand all. Does it expand? Let's sign up. It does, okay. Right, the first few questions are really just number crunching. If you go and look at the notes, like this one I'm looking at right now, you know, to change from polar to Cartesian and Cartesian to polar, it's virtually the same process, right? So I don't really want to spend any time on that. Okay, here would be a classic example of the similar kind of question that we've just done. The triple integral is E. E is a cylinder between 0 and 6. I did what, from 1 to 4 or 5, I can't remember. And I made this 7. So that is very similar. What's the square root of x squared plus y squared going to eventually become when you do the polar part of cylindrical coordinates?
R.
It's going to become r. So you see how easy that question is to do. It's dead easy to integrate an r or an r squared, right? It's much more difficult to integrate the square root of x squared plus y squared, right? It just is, right? It's a bit like me saying integrate the square root of x squared plus 4. Can you trust me that that's actually a 10 to 15 minute question? Because you'd have to do some kind of weird x sub on it and who knows where you'd go. So it's probably not a good idea to choose that one. Now, looking at this next one, it's still the same situation, but it's got a little bit more going on. So I'm going to write this one down. I think I'm going to have to make this the last one for today. So we've got a z, and we've got the usual dv, and z is going to go from x squared plus y squared, and then it's going to finish on 16. So actually, I'm going to do a different thing. I'm just going to set this guy up and then leave it, because that gives me a chance to do 7, because 7's got some cool things going on as well. Okay, so are we back to seeing my screen with the paper on it? Right, here it goes. See this guy here? That tells me that z is going to go from 16 to x squared plus y squared. So if you ever get a question in cylindrical coordinates that goes from z equals x to z equals x squared minus y squared, you know, anything that looks weird like that, that's going to be your z, guys. And right now they've got x's, but we'll cure that in a minute, right? We'll cure that later. Now, what you are not so sure about is, since that's all they've given me, I need to know what the floor looks like. You know, the xy floor looks like. And then once I know what it looks like, I can turn it into r's and theta's. Well, if you think about this and you match them, can't you see that the floor looks like a circle of radius 4? That makes sense. You match the z with the other z, right? So we are looking at the whole circle. So I guess that's from r equals 0 to r equals 4. And since it's a full circle, it's from 0 to 2 pi, right? While I'm at that, do you know sometimes they say to you things like, and it's in the first octant. You know, I've seen a question, at least one, if not more than one, that had this. And it's in the first octant, right? That will only change one piece of this entire integral here. Only one piece actually changes. Who changes if it's in the first octant?
2 pi.
Yeah. And instead of going 0 all the way around the 4 quadrants, you know the 4 quadrants are called octants because the 4 quadrants have 4 guys above in the z direction and another 4 below. So if you can think in 3D, there's 8 regions of space in 3D. And the first quadrant is everybody positive, which is the typical one. So if that was the case, wouldn't this change from 0 to ½ pi? So if you get a question and your answer is 4 times bigger than what it should be, maybe you didn't read the and it's in the first quadrant bit. Now, z is good. It's going to go z. It's going to go z. It's going to go dz, r, dr, d theta. So in this question here, I think we're pretty much done. Would you agree that it's just a matter of integrating Z, plugging in the guys that you've got? Nah, there is a fella I've just noticed that I should have fixed, and now I'll do it. Z equals 16 is good. Z equals x squared plus y squared should not be left in that format. Shouldn't it be converted to r's and thetas? And what's the x squared plus y squared going to get me?
R squared.
There. Are we happy about the setup now? I think if you get the setup right, most of the time, isn't the rest going to be pretty mundane? Right? It's just integrals with r, theta, and z, and you do what you do, and you take as many shortcuts as you can see to make your life easy. I'm going to leave this one as is then. We cool? Right. Right. Next fella I want to kick back to, which is why I only set that one up. Oh, it goes to the start each time. Go figure. If you look at question 7, we're doing an x take away y over some region E. And E is described as a region between these two cylinders, and it's above the xy plane, and it has z equals y plus 5, right? So a lot of information going on in this one. And strangely enough, the answer is negative. It's okay for a triple integral to be negative, just in the same way it's okay for a single integral to be negative. What that means in physical world, I don't know, but it's okay. So let me stop sharing and see if we can set this guy up, because that's really all we have time for. Now, I know it's going to be dz. I know it's going to be r, dr, d theta. That part of the setup is pretty standard. I'm not going to get too confused about that. Do you know the x minus y guy has to be converted? X is r cos theta. Take away r sin theta. Happy about that? Now, let's see if we can figure out what the z's look like. The z is going to come from the information that it's above the xy plane and that z equals y plus 5. Now, the fact that it's above the plane tells me that that is 0 and that is y plus 5. They could have just said y equals 0 to, z equals 0 to z equals y plus 5, but they kind of phrased it that way, so I can live with that. Now, these two guys here, if you draw a little sketch of them on the xy plane, it might help you see what you're getting. Aren't you getting a donut? Agreed? Now, when you try and generate this shape, the r value goes from 1 to 5 because the radius is 1 and the radius is 5. So the 1 to 5 will generate it. On the other hand, you know that theta doesn't really change much. So we have got the integral from theta equals 0 to theta equals 2 pi. We've got the integral of r equals 1 to r equals 5. And then we've got z equals 0, which I'm happy about. What do you think I'm going to do about the y plus 5, which is the other guy?
Convert
R
it.
sine of theta.
Right. And I heard someone saying convert, and I'm sure they were going to say that fella, right? Now, they could have made Z a lot uglier. Couldn't have made Z x, y plus y cubed or something if they really, took a mind to it. In fact, couldn't they have Z as some region above the XY, some region above that cylinder and some region below that cylinder? So can you imagine you've got a hollow tin can going up the way, and then they've got a curved surface on the top of it, and another curved surface on the bottom of it, and that's the fella that E is represented by, right? So you could have done anything. But pretty much I would probably take out the R as a common factor here. While I'm at it, I'd bring this other R into the storyline. And oops, a dr, dz, d theta. So 0 to 2 pi, 1 to 5, 0 to r sine theta plus 5. And now when I look at the guys that we've got, which are a right mess here, it's a dz, dr, d theta guy. First time round, you're going to do that integral, right? Then you'll be left with nothing but r's and thetas all over the place. It'll be a pretty messy thing. But whatever it is, it'll go in there, right? And then you can worry about maybe separating out some bits to try and make your workload a little bit easier. Sometimes you can't do much about it. Sometimes you just get a mess that's too intertwined that you can't separate the r's and thetas. So can you imagine it was r squared sine theta plus r cos theta or something? Right. You might be able to pull it in r, but is it worth it? Probably not. If you can separate all of one variable from all of the other variable, I think it's worth it to do the separate them into bits. But see if you can only kind of half-heartedly do it, it's probably not worth the effort. Because at the end of the day, you're probably doing the same amount of work. You're just moving it a little bit to one side rather than doing it, just bite the bullet and do it once and get it over with. But that's the technical part of how to deal with that. And that's kind of me for today. Any last questions? Are we good? Do you feel better now than you did an hour ago? Right, good. Because if you felt worse, then that wouldn't have been a good lesson. Okay, you know the usual. You need to see me. You want to shoot me out an email. Oh, I sent out your grades. Did you all get one? Okay, so that's covered. If something doesn't make sense, the homework and the quizzes are basically together, and they're 30% of your grade, and the two tests are together, and they're the other 30%. So when you look at it from that perspective, do you see how much importance you should be putting on doing well in your tests? Because they can pull back, you can recover poor homework assignment completion by doing really good in your tests. Not that I suggest you do that. I think if you do a lot of homework, you'll probably find the test much easier. And so both work hand in hand. That's it. Have a nice day, everybody. If anybody has a one-on-one question, you might want to wait until everybody's gone and then you can just ask me it. Otherwise, bye.
I had a quick question.
Sure.
About the grade. Are we going to be getting feedback back for our exams, like our working on them?
Simply just the workload that's important. It would be horrendously difficult for me to do it for everyone. If you've got a particular need, then I can certainly look at it and do it as a one-off. But I don't want to kind of commit myself to doing it for everyone. I've done it for a couple of students, and it takes me about half an hour, which might not sound a lot, but if you do 120 students times half an hour, it ain't happening. I'd been week 5 by the time I'd finished the first test. I wouldn't get through them all, right? So if there's something that's really, don't let me put that off. If you're really concerned about your grade and you think, look, I must be doing something really bad and I just don't know what it is, shoot me an email and I'll have a look. And if I see anything significant, then I'll tell you what that is. A lot of the time when I've checked it, it's been It's been good. Most people are doing the right process, but these questions are so bloody long. Isn't it easy for a 2 to turn into a 4, or you calculate something with an extra x that you didn't mean to, and because of that, the answer comes out wrong. I still regrade it. That takes me enough time actually to do. So you get partial credit for that. So in general, most people are doing it right. They just, the process they're doing right. They just sometimes fall down on the details. Okay, so if you can shoot me an email in private about that, and I'll look into whatever it is you ask me if you ask me.
All right, that's really helpful. Thank you.
Okay, anyone else?
I had sent you an email. I'm just wondering, did you get it? Because you were saying like sometimes you didn't get emails.
When did you send me it?
Sometime last night, I think.
Ooh, I think I should have got it. If you can wait patiently, I'll see if I can get in and out of this thing. Emails. I'm in the emails. Not that one. You sent it through Canvas, or you sent it direct?
Direct.
Okay, let's have a look. And you sent it last night sometime?
Yeah, it looks like 9.
Right. Where are we? Well, Tuesday. 3 o'clock Tuesday. No sign of you yet. 5 o'clock. Yep, I've got you here.
Okay, thank you.
Yes, I can answer that question pretty quickly. Yeah, I can answer that question. If you hold off for 2 seconds, I won't mention the number, but I'll just double check that I can get that information for you without too much trouble. I think I saved that even though I didn't use it.
And you're saying
Yes.
that, so how much were the tests weighted?
The test will be 30% of your grade. So each of your tests basically is worth the same amount, but as a total, they're worth 30% of your grade. Does that make sense?
Yeah, thank you.
Right. Okay. I have got your 2 numbers. I'm going to copy that. I think I've got you set up in the homework. I have. Right. You're going to get a very, very short email back from me. Just going to have 2 numbers. The first one is test 1. The second number is test 2. And it is now being sent.
Okay, thank you.
You're welcome. Okay. Who's next in my list of people who may or may not want to talk to me? You are the last one. Bye-bye.